so that I will be able to share it with you. Again, good morning to everyone. Until now, we have talked about several things in statistics, you know. The topic in statistics we have covered so far are the point estimations, okay? The second thing we talked about was confidence interval estimations, right? So this is what you have done in the homework. What was point estimation? We were finding the mu and sigma using the X bar and the standard deviation. We were finding the T interval and Z interval using a certain confidence interval levels in confidence interval estimation. Now the last part in this whole estimation thing is called the hypothesis testing. Hypothesis, okay? Do you know what hypothesis is? From science courses, we learn hypothesis. Can you write what a hypothesis is, arkadaşlar? Hypothesis. Hypothese in Turkish. What do you know about hypothesis? Let me check my chat. Thesis to be tested. Bilal said, thesis to be tested. Very nice. Thesis means our assumptions, right? Or my research question. There is one thesis in my research question. Does this affect this kind of, or I would say, this is equal to that kind of assumptions or propositions, okay? Argument that suggested, that's what Ahmet Furkan said. So this time we will be talking about hypothesis testing. As you will remember or see, most of the topics are really very integrated to each other. They are very highly similar to each other. Like when we talk about point estimation, it's very similar to confidence interval estimation. And now when I talk about Z-test, T-test, those kind of hypothesis testing approaches, they are really very similar to confidence interval estimation. So I want you to grasp the main idea behind this topic, and it is really very, very similar and very easy to follow. Today I will be talking about these topics, which I won't go over right now. But they are really very important, and we use these kind of things in our research, arkadaşlar. In my research, in all electrical engineering topics, people perform such hypothesis testing, even though they might not know that they are doing some hypothesis testing, but they are doing it. We will do some kind of very, very fast recapitulation. Recapitulation means just very small review of what we have discussed about statistics until now. You know, population includes all possible values. Sample is a portion of the population. Using a statistical inference, çıkarım, we are trying to generalize from a sample about the population parameters, right? With a calculated degree of certainty. That means 90% confidence, 95% confidence, 99% confidence. This is what we do using statistical inference. Evet, aramızda yeni uyananlar var, esneyenler var. Mute'u alırsanız arkadaşlar, şöyle bir bakalım. Mute'u olmayanlar var mı aramızda? Evet. Abdullah Hamdi. I heard your yawning. Evet. Peki, let's continue. As I said before, there are two forms of statistical inference. One of them is estimation that we did until now. The second one is hypothesis testing, which we will do today, which we will cover today. Okay. As we remember, parameter is something, a characteristics of the population, such as the mean, variance, median, proportion, those kind of things. And statistic is the kind of something we calculated from the data, right? Do you remember this sample mean, sample standard deviation, sample proportion. This is a very short review of what we have said before. Arkadaşlar, this is a little bit tricky. I want you to focus on that. If you remember, when we talk about the source of, let's say, population, the parameters are coming from the population, okay? The statistic is coming from the sample, that as we discussed before. In terms of notation, we said mu and sigma as the mean and the standard deviation. But in statistic or samples, we use x bar and s, right? So the parameters do not vary, they don't change, but statistics may change from sample to sample. This is critical, arkadaşlar. Parameters are fixed, they are coming from the big population, but statistics can change from sample to sample. We are sampling 100 people, I get a value. I sample another 100 people, I get another value. And these values may be different from each other. So this is something that we should be aware of, okay? The parameters are not calculated. We don't calculate them. They are given to me, okay? The parameters are given to me. Mu or sigma are given to me. But for example, X bar or S or population sample proportion, we calculate them from a sample, okay? This is a nice kind of comparison between parameters and statistics. If you remember this, this stuff over here, we have population. From the population, we take a sample, we obtain our data, we find our statistic. From the statistic, we infer, we do some inference and find out the parameter itself. What is the population mean? What is the population variance? What is the population proportion? What is the population median? All those kind of things are inferred from our statistics, our sample data, right? So you again remember this from the central limit theorem. If we sample from a population, let's say n samples from a population, and then when we take the averages of those populations, of those samples, the distribution of those averages, distributions of those means will have a normal distribution, okay? So the sampling distributions of a mean will describe such a sampling mean, and it will have a normal distribution. And in that, we also mentioned standard error of the mean topic, which is like sigma divided by root n, okay? We are all together, we remember all these, right? So let me jump into the hypothesis testing part. What is hypothesis testing? Arkadaşlar, I will explain this with examples, and it will be more apparent, more obvious to you as we go further. The general hypothesis testing, we will have a hypothesis, okay? Then we will say, what is the, is this hypothesis correct or not? Okay? We will test this hypothesis by performing some statistical approaches, by using some statistical approaches. We have done similar things. For example, it's the main use of this hypothesis testing is to determine whether a specific treatment or methodology or approach has an effect on the individual's products, materials, and population. Let me give you one example. For example, you have a certain you have a certain population here, okay? This is population 1 with a certain, let's say, diet, okay? You have a diet here. You have another population, population 2, okay? We did such example before, population 2. There's another, this is diet 1, there's a diet 2. Let's say this is protein rich, this is carbohydrate rich diets. And we are trying to find out if the mean weights of these people are equal or not, okay? So a specific diet, does it affect the mean weight of people, okay? We are performing a certain, we have a population 1 with no drugs, okay, with no medicine, okay? This is, let's say, control group. And we have performing, we are prescribing those people with a certain medicine. We give them pills, okay? They take those pills. And then we look at their, let's say, blood pressures, okay? Or blood glucose levels, okay? So we are asking, we are testing if these two blood pressure levels are equal to each other. But we will be testing, we will have a hypothesis, okay? Before starting everything. We will say that this medicine does not affect the blood pressure. This is what we will be hypothesizing, okay? Then we will test whether this hypothesis is correct or not. Arkadaşlar, did you follow me? This is critical. What is hypothesis testing? We will have the situation 1 and situation 2. Situation 1 will have certain values, certain population characteristics, and we will perform a treatment, a methodology, an approach. Let's say I have a certain product and I have an error rate here, okay? I have, let's say, 1% of the products are erroneous, they are problematic, and I take other proportion with another production line methodology. I have another production, let's say, methodology in my factory, and I also find errors, production errors, manufacturing errors, and then see if this new methodology affected the outcome. Okay, this is what we are trying to be asking, and there are some steps in this, arkadaşlar. Very easy topic. I'm sure you're gonna grasp it in the first explanation. In this whole stuff, we will be having a null hypothesis. Null hypothesis. You will learn this more. Null hypothesis. Sıfır. Null means sıfır. Okay. An alternative hypothesis, and we will have an alternative hypothesis which will be against null hypothesis. Okay. Then we will perform some test statistics, such as from mu's to z, from mu to t value, those kind of things. And then we will perform the p-value stuff, like alpha, comparison with alpha, okay, the probabilities. Okay, we really know these stuff, but it will be in a different context. And this alpha value will be our significance value, and we will say that 90% confidence, we have 90% confidence that this sample statistic is supporting the idea of null hypothesis or not, okay? This is the basics of null hypothesis or hypothesis testing. Let me go one by one right now. Okay, the first, and let me remind you that this topic is the core of your term project, okay? I wanted you to come up with null hypothesis and alternative hypothesis for your research questions in your term projects, and you will have a null hypothesis and an alternative hypothesis. For example, you might be asking if the let's say heights of male students and heights of female students are equal to each other. Okay, this will be my null hypothesis. Weights or heights of my female students, weights or heights of my male students are equal. Okay, the average weights of this population, average weight of this population is equal, means null hypothesis. Okay, mu, let me write here, mu, let's say mu1 is the weight of males, average weight of males. Mu2 is the average weight of females. Okay, and we will say null hypothesis says that these are equal. Okay, this is called H0, null hypothesis. Hypothesis, null hypothesis. 0 means null. Okay, null hypothesis always says that they are equal. Okay, let me think about the diet problem. This is the mean blood pressure or mean weight using the diet number 1. Mean weight of people using diet number 2. And I say my null hypothesis is that they are equal. That means there is no effect of diet on my mean or average weight of people having different diets. Okay? Or I have one approach with a certain production line, and I find the proportion of erroneous products, and I have another production line approach, and I have another proportion of erroneous parts, and I say this proportions, let me say proportion 1 is equal to proportion 2. Okay, this is called null hypothesis. What is alternative hypothesis again? What is the alternative hypothesis arkadaşlar? If I say this is equal, what would be the alternative hypothesis? Can you write to the chat? What would be the alternative hypothesis? Yes, not equal, or any other alternative hypothesis you might think of? Any other, like not equal is one alternative hypothesis, as you mentioned. Okay, mu1 is not equal to mu2. How about any other alternative hypothesis you might think of? Can this be like mu1 greater than mu2? Yes, Mohammed Muhsin. One of them is greater than the other one, or vice versa. Mu1 is less than mu2, right? So we might have these kind of alternative hypotheses. I will give examples of them. I hope, yes, Ömer, different than means this, right? Mu is not equal to. P1 is not equal to P2, okay? So the first thing, I have the body weights of male students, body weights of female students. What is my research question? Is the gender, does the gender affect the body weight? Okay, it's an easy question. We know the result, but let us pose a research question like that. Does the gender, okay, affect body weight? This is my question, research question. How will I convert this to a research question arkadaşlar? The body weight of male students from a sample, body weight of female or male students from another sample. I will have average weights and compare them. And I will say, null hypothesis, their weights are equal. And as an alternative hypothesis, their weights are not equal. Or the average weights of males are greater than average weight of females. Okay, this is something that we might be doing. So first step is converting the research question to a null hypothesis. Okay, here what I say is null hypothesis is a claim of no difference in the population. Okay, no difference in the population. That means no effect. There is no effect of diet on this. There is no effect of gender on the body weight. There is no effect of production line setup in this. Okay, there is no effect of this drug in the cancer treatments. Okay, this is all very similar problems. And alternative hypothesis claims, bakın, claims H0 is false. That means it is not true that there is no difference. Okay, null hypothesis says no difference between these two things. Alternative hypothesis always says yes, that's not true. H0 is false. Okay, that means no difference in the population claim is false. Okay, and what should we do for that? We're going to collect data. We're going to seek evidence against H0 as a way of strengthening HA, which is we are trying to find out if there is an effect of my treatment, if there is an effect of this drug, if there is an effect of this production line setup on on the proportion, on the mean, on the variance of something. Okay, this is how we will go further. I hope you got the main idea, right? So in terms of null hypothesis and alternative hypothesis, this is the case. Let us go to the next one. Do you remember this body weight problem we mentioned a couple of weeks ago? Do you remember this, arkadaşlar? In 1970s, 20 to 29-year-old men in the US had a mean body weight of 170 pounds. Standard deviation sigma was 40 pounds. We test whether mean body weight in the population now differs. Okay, what is my research question? What might be my research question in this problem, arkadaşlar? Let's say I'm a dietetic expert, and I am trying to find out what is that I am trying to find out in this problem. You're writing. Yes, is obesity increased in the population? Is there a difference between, let me read Ömer's, between 70s and now? Their mean weight will be increased after marriage. Yes, maybe that's another research question, Abdullah Enes. So if male or females, does the average body weight, is the average body weight affected before and after marriage, right? This is another research question. Very nice. But here we are trying to find out if the obesity level, if the body weight is now increased. What would be the H0, arkadaşlar? What would be H0 here? What would be the H0 here? Can you write? No change. How would you write this in statistical terms? Very nice, Ahmet Furkan, thank you. What is U, Samet? U? Mu, you mean, right? Mu. Yes, thank you. So, what is sigma 1? Arkadaşlar, sigma 1 is, sorry, not sigma 1, what is sigma 1? Null hypothesis is mu is equal to 170. What is mu? The body weight now is equal to the body weight in 1970. Okay? What is the alternative hypothesis? Either we will call two-sided test, okay, which is not equal case, or one-sided test, this is greater than, okay? These are alternative hypotheses, either one-sided or two-sided. One-sided means greater than or less than. Two-sided means is not equal. Okay, this will change the p-value that we will be asking. Okay, that we will be using. Is that part clear, arkadaşlar? Is this part clear? Like from a problem, can you form a null hypothesis, an alternative hypothesis? Yes, very nice. Thank you very much for your responses.
Hocam, I have a question.
Sure, Ömer.
Hocam, how we can sure that there is a difference with statistical value? So if it is 60% of difference, yes, be difference. Or what is the number that we need to be sure?
Thank you, Ömer. This is the topic of this this chapter. That's what you're asking is very critical. So how will I be sure that there is a difference, statistical significant difference or not? So today or on Thursday, I will try to explain to you how would I be sure or how will I put my words, put my sentences in order to show the effect, okay? So this is what we will be covering. So we start with the hypothesis, then we test the hypothesis, then we talk about the levels, confidence levels, and then we will say 90% or 95%. We are sure 95% of the time that this sample is indicates that there is no statistical significance, or there is a statistical significance here. Okay, so this is what we are going to be doing in this chapter. So that's a nice question. We have a research question, but how can we be sure that we are doing the correct thing? This statistics, the science of statistics shows us a means, the way that we should follow in this whole process, okay? So the second thing is, what I would be telling you here, what did we do, arkadaşlar, in the previous chapters? If you remember, if sigma is known, we were doing z. If known, let's say, if sigma was not known, it wasn't given to me, what was the thing that I was doing? I was finding the S, and from that I was using the T, right? T distribution. So Z distribution and T distribution. Same thing here. If I know sigma from my previous knowledge, let's say I have collected many data from my manufacturing line, from my patients, from my material, from my construction projects. I know them from previous knowledge, okay? Then if this is the case, I should be using the Z statistic, okay? How will I do that? Do you remember the Z statistic situation, arkadaşlar? How do I generate a Z statistic from my data? I have my data here, okay? Values. I have my data. How will I come up with a Z statistic? Any answers? What were we doing, arkadaşlar? From this, we were finding X bar, and we know how many samples I have here. I know sigma from my previous experience. I know mu 0 from my previous experience, right? Thank you, Beyza. Nice job. X bar minus mu 0 divided by sigma root n, right? This was what Z statistic was about. What shall we do right now in this problem, hypothesis testing? What is that X bar in my hypothesis testing? What is mu 0 in my hypothesis testing, arkadaşlar? What is mu 0, for example? What is mu 0 in my hypothesis testing context? For example, in 1970s, the average body weight of male people, right? Body weight of male people in 1970s. It is given to me. Mu 0 is given to me in the original research. For example, I did a research in 1970s. I have data from that. I know the parameters, let's say. I know the mean and the sigma values from 1970s. Now, what is my research question now? I am trying to find out if the body weight now is different from the body weight back then, okay? So this is given. This is given because I know how many data I have collected so far in 2020. This is coming from 1970s, okay? This is coming from 2020 because I'm collecting this data right now from male people between 20 and 29 years of age, right? This is also given to me from 1970s. You get the point, right, arkadaşlar? So How will I do that? This is my X bar, mu 0. This is Z statistics that we have mentioned before. So what is mu 0 critical? Why is mu 0 critical? Mu 0 is the basis of my hypothesis testing, okay? Because if I'm asking myself if H0 is true or not, okay, this is the null hypothesis. H0, null hypothesis. What did H0 say? Now, the population right now is equal to population back then. Okay, this is my H0. And I'm trying to find out evidence against this. Okay, I'm trying to find out if this is true or not. Okay, so how will I do that? I will obtain my Z statistic again, something that we have done before. Okay, now what should I do? What should I do, arkadaşlar? I have my distribution, right? I have my distribution here. And this is, what is this point, arkadaşlar? What is this point in Z distribution? 0. I have my Z statistic from my sample. And I was finding the alpha value, or we will call it P value, okay? So I will do this kind of a thing, okay? Bear with me, and I will try to explain more on this, okay? So what we have done before is the following. If you remember, my mu 0 was 170. My sigma was given as 40 pounds. And I take 64 people as my sample. Bakın, burası kritik. I am taking a random sample of 64 people. And I'm saying, by looking at this 64 people sample, can I infer can I infer something? Can I say something about the general population? I'm trying to say that, right? I'm trying to find out one random sample from the current population, as much representative as possible. And what is my goal again? I'm trying to test my null hypothesis, whether the body weight now is different from body weight back then in 1970s. Okay, so how will I do that? I will obtain my Z statistic using this sample mean or coming from my data. Okay, sample data or random sample. Okay, I found this from my sample, arkadaşlar. Okay, so what did I find? I found my Z as 0.6. Like 60 divided by 8 is 5. 173 minus 107 divided by 5 is 0.6. This is something that we have done before. Okay. So what is that I am trying to find out right now? I'm gonna focus on this Z statistic. Okay.
Hocam, I have a question about mu 0. Can you? Yes. Hocam, mu 0 is 170 at 1970, right?
Right. This is given to me.
Yes. It is. Will we say that it is the population mean of population or
population, not sample? We will assume that this is the population mean. Okay. This is the population mean.
But if we make a research, we will consider about this 170 is sample mean, right?
In the next part of this lecture, I will tell you this is not an actual situation. Usually, we sample here. We sample. Let's say we sample from a certain population. We have another sample from another population. We don't know the means and standard deviations of both situations, and we will compare them. Okay, this is another way of testing a hypothesis. Here, we are talking about z-test. That means we know the mean, we know the sample variance. Okay?
Okay,
This
hocam.
is the
Thank you.
first paradigm. The second paradigm will be like, we don't know sigma. Okay? Then again, we will not know mu. There is another way of doing all these one by one. Okay? This is the first thing that we will be doing. Maybe from the previous research, it is given to me, this is the population mean and population standard deviation. Or we don't know it, and we also, as you said, we also took it from a sample. It's not coming from the whole population, right? So this is what we will be doing as we go further. But my point here is, we take a sample and we obtain 173. Okay, here we take another sample, it is 185. Okay, so before it was 0.6, now it is point, not point, it is 3, right? So here the z value was 0.6. This is the z value, 3 points. This is what, arkadaşlar? Can you determine the z value here? Can you determine the z value for this value? Yes, Mohammed Muhsin, thank you. 164 minus 170 divided by 40 divided by 64, right? So this is 6 minus 6. This is 5. That means minus 1.2. Okay, so what are we doing here? This is the distribution of means, sample means. Now I do this 0 here. 170 becomes 0. 185 becomes 3. 164 becomes minus 1.2. 173 becomes 0.6, right? This is what we do. From the sample, I convert it to z. From the z, what do I do, arkadaşlar? From the z value, what do? I go from z and find out from my z table, değil mi? From the z table, I will find out the probability value, right? Probability of z greater than 100 and let's say 0.6, or probability of z being greater than 3. This is what we have done so far, right? It was here, and probability of z being greater than 3 will be here. Probability of z being greater than 0.6 will be something here, right? The area under this curve. So it will be, we found these kind of things from the z table before. What are we going to do right now? This is the most critical slide that I would like to take your attention to. If my sample mean, if my sample mean close to H0, if my sample mean is close to H0, close to H0 means it is close to the given mu value, right? 170. If it is close to that value with in a certain boundary, okay, then we will say that the null hypothesis is true. I will obtain a sample mean over here, over here, over here, over here, over here. Okay, all these sample means will support H0. What is H0? There is no difference. Okay, there is no difference between body weights. If I obtain a value over here, it means there is not enough evidence against H0. Null hypothesis. I'm trying to reject null hypothesis. Can I reject it with such an X bar value? No. I don't have enough evidence. Elimde yeterince kanıt yok. Zıddını ispat etmek üzere elimde yeterince kanıt yok. Okay? That's what we should be thinking about. I have a sample mean, and I have my mu0, and I will compare them, obtain my Z statistic. From the Z statistic, I will say, if it is in a certain boundary, then I can say that null hypothesis is true. If I obtain extreme values, Z values over here, Z values over here, or mu values very far away from the mean value, then I would say null hypothesis is false. Okay? The outcomes of this hypothesis testing is I either say H0 is true, okay, or H0 is false. This is what the outcome of this hypothesis testing. H0 is true means I might be highly sure that with a certain confidence interval, with a certain confidence level, I might be certain that the sample mean that I obtained from this sample is not statistically significantly different from the mean in 1970s. Burası anlaşıldı mı arkadaşlar? So I obtain samples, sample means, I obtain sample means here. Then I check whether the sample mean is close to the actual mean of the population. If it is really close with a certain predefined level, then I would say, yeah, this is the H0 is true. We will have high probability of H0 being true, okay? I hope this is clear. Here we will use p-value arkadaşlar. P-value, which is something that we again discussed before. P-value answer the question, what is the probability of the observed test statistic when H0 is true? This is something that we have done before, right? So this is the p-value arkadaşlar. For 173, I found my Z as 0.6, and I find the area under the curve, which is the probability. This will be my p-value. You will hear this in statistics a lot. P-value, okay? What is your p-value? Okay? So, if this p-value, bakın, we will convert Z, and then we will obtain our p-value. Tamam mı? If it is one-sided, bakın, if it is one-sided, we will keep this p like that. If you remember from our previous discussions, if it is two-sided, then we will multiply this p by 2. 2 times 2.0.27. Okay? So if it is one-sided, I will keep my p as it is. If it is two-sided, where is this to one-sided, two-sided coming from? Our alternative hypothesis. I might say from my alternative hypothesis, if this is not equal, this means two-sided. If it is less or greater, then one-sided. Anladık değil mi burayı arkadaşlar? One-sided, two-sided, p-value. So we will again find the probabilities. For example, for 173, I obtained this p-value. So this p-value will be something that I will be testing or concluding, okay? So for example, 185 is my average body weight that I obtained today as my sample mean, and the Z value is 3. From this 3 value, what will I find? I will find my p-value. Everything is not finished yet. P-value is 0.001, 1 in 1,000. So the probability of obtaining a value which is greater than 185 is 1 in 1,000. Very rare, very extreme. Okay? Obtaining is for what? When the mean is 170, obtaining something here is very low probability, has a very low probability. So what should I say? My hypothesis is this is equal. My the body weights now is equal to the body weights back then. And I'm obtaining 185 pounds. What shall I say? This is highly unlikely. This is highly unlikely. I won't say it is not true. Bakın, istatistikte bu çok kritik. We always say, we don't say that they are not equal. They are not, this is not true. Okay, what do we say? It is highly unlikely that this, this sample is equal to the body weight of today is equal to body weight of 170s. Okay, it is highly unlikely because the probability is very low. Okay, so if it is two-sided, we multiply everything by 2. Okay, so what is my interpretation? I'm finishing my class in a couple of minutes. So what is the interpretation? Arkadaşlar, if I obtain smaller p-values from my z, okay? So I have my mu. From my mu, I obtain my z. From my z, I obtain my probabilities, p-values. If they are small, what does it mean? It is very unlikely. It's an extreme value, okay? It's an extreme value. So that means I have strong evidence against H0. What was H0? Mu1 current body weight and body weight back then is equal. This was my null hypothesis. What do I say if I obtain very low p-values? I say that the mean now is equal to mean back then. Hypothesis, I have strong evidence against this hypothesis. Burası kritik. İstatistik jargonunda şöyle demiyoruz. Bunların body weight'leri eşit değil demiyoruz. Ne diyoruz? I have a strong evidence against the hypothesis that they are equal. Okay? So, small p, strong evidence. If I have, let me show you here. If my p is greater than 0.1, I have non-significant evidence against H0. Bakın tekrar şuraya çiziyorum. I have my distribution, z distribution here. My p-value is somewhere here, which is, let's say, 0.225. Okay. So what should I say? I have not strong evidence against H0. I do not have a strong evidence against. I do not have strong evidence against strong evidence. Yani her şeyi şu evidence üzerine kurguluyorum. This is my null hypothesis. If my p-value is high, I say I do not have strong evidence. So it is called non-significant evidence. Anlamlı, istatistiksel olarak anlamlı olmayan bir kanıt. If my p-value is between 0.05 and 0.910, then it is called marginally significant evidence. If it is between this value and this value, it is significant evidence against 0. And if it is less than 0.01, we call it highly significant evidence against H0. Anlaşıldı mı acaba arkadaşlar? Ömer, your question was something like that. So we have certain probabilities, and I say if this is 0.26, non-significant evidence. If it is 0.001, as we found from 185 pounds, then I would say I have highly significant evidence against A0. Bakın 27 non-significant, 0 highly significant evidence against A0. I hope this is clear on your side, and this is the end of this live lecture, which is like 50 minutes. I hope you got the main idea here. Do you have any muddy points, anything that troubles you arkadaşlar, anything that you don't couldn't understand? Let me remind you one thing again. Let me remind you one summary slide. I will start stating my hypothesis. I will start stating my null hypothesis first, and I will come up with different alternative hypotheses. Then I will find my test statistic as Z. From Z, I will find the p-value. Then I will look at if I have strong evidence against H0 or not. Okay, that's the main idea of today's talk. We will continue on Thursday with some other extensions of this current situation. Okay, so we will tell if sigma is not known and such. We will talk about type 1 error, type 2 error, and this is all we will be doing. Evet arkadaşlar, thank you for your attention and contributions and your carefulness. Any problems arkadaşlar? I hope to see you on Thursday, and